Hey guys, it's Isaac Frank and welcome back to yet another video on the Solidity tutorial series. So in this video we'll be talking about structs, or also known as structures. So struct isn't complex, it's not hard to understand, so we won't waste much time on this particular topic. But these are the points, the topics would cover concerning struct. So the first here is what is a struct? Structs are common type in Solidity, and they basically enable grouping of different data type together. So how do we define a struct? To define a struct, you make use of the struct keyword. I'll just give my indentation. You make use of the struct keyword, and then you give the struct a name. So we'll give this let's say students. So you make use of the curly braces. So in this curly braces, you give the struct the properties. The properties are the different data types you want the struct to have. So for the sake of this tutorial, I will give the struct a string and also give it int age. So we're just saying a particular student should have a name and an age. So this is how we define a struct. So we define the student struct, but how do we make use of this struct? We'll go back to declaring struct. So there are three ways to declaring a struct in Solidity. The first way is known as the conventional or the methodic way. The methodic way is a process whereby you declare a variable and initialize it in a method. So we'll declare a variable, and this variable will be of the data type of this variable will be our struct data type. So we're declaring a variable. We'll call this let's call this students, and we've declared a variable of data type student. So in a method, so in the method right now, the methodic way, in the method you can start initializing the properties of the struct. So we'll use the dot notation. We'll get the variable, which is students, and then making use of the dot notation, we'll get the properties of the struct. So we'll get the name, and here we can assign it to something, and we'll do the same thing for the age, and also we assign it to something. So this is the methodic way of initializing a struct. You declare a struct, and in a function, the methodic way, in a method or a function, you assess the properties and assign them to a new value. The next way to initializing a struct is known as the readable way. So this is a process of let's see, this is method 1, and the second way is the readable way. So the data type of this variable will still be a student's data type. So this is a custom data type, so it'll be a student data type, and I should just give this some gap. So let's call this student 2. We'll call this student 1, and this student should equal to a struct. Since we are initializing it to a struct, we make use of the struct name, which is student, just as if we are calling this as a class or as a function. We make use of parentheses. Then in this parentheses, we need to initialize the name and the age. So to do that, we use a dictionary, or we use the curly braces, and this is known as a dictionary. So in this, we'll specify the name and initialize it to something, and specify the age and also initialize it to something. By default, the name will be an empty string and the age will be 0. So we have to initialize it to something useful. So we use the name. This is just like a JSON object. So the name, we initialize it to something, and the age also, we initialize it to something. So this is the second way of initializing a struct. So the next way we'll talk about is the third way, which is known as a shorter way, and this is the process of still doing almost the same thing with this. So we'll create another variable, and this will be a student 2, and also it should equal student, just like we're calling it as a function. And instead of using a dictionary in here, we'll specify the name and the age. It becomes as if this is a function and these are the parameters this function accepts. So the first value will be the name, so we'll use this, and the second value will be the age, and we'll do this. So this is the third way of initializing a struct. So then, how do we assess a struct properties? How do we assess a value from the struct? So no matter the method you use in initializing a struct, whether you use the method one, the methodic way, or use the simpler way, or use the shorter way, the way to assess a struct is to make use of the variable you need, the struct variable, which is student 1, student 2, and student. So once you get the variable using a dot notation, you can get the properties, and this returns the value for you. Then use the equal sign, you're reassigning it to another value. But this line alone, this line returns the initial value, which is an empty string. So adding this to it, you're initializing it to something else. So this is a way to assess struct properties. So next we have here our recursive structs. What are recursive structs? A struct is said to be recursive when it has its own type as a property. So this is a struct. It would be ideal for this struct to have a student in it. So if you check this should give a recursive struct definition, because this struct to be recursive, if a user should try to using a dot notation and the user gets to this student will return a new set of attributes, which is not ideal. Yeah, okay, so this is what is known as a recursive struct. So a recursive struct can also occur if we have another struct. Let's say these are the teachers, and these teachers have a student struct in it. This student struct also have a student struct in it, and here we're trying to initialize it to give it a teacher's data type. So as you can see, we also get the recursive struct because the same thing also happens. If it goes to the teacher is returning a student struct again. So this is a cycle that never ends. That's what's known as a recursive struct. That's all for this video. In the next video, we'll be talking about mappings, and thumbs up this video if you like it, and if you got lost along the way, feel free to leave a comment in the comment section below. Thanks for watching, and goodbye.